or something like that. Okay.
What number that you see? What does it represent?
Okay,
Density?
so these instruments are calibrated in the lab to basically give PM10 reading, PM10 concentration. So this is now saying, 39 micrograms per meter cube of PM10, and they are calibrated with Arizona road dust, which is basically similar with other kinds of dust. And they're optical instruments. As I say, they're calibrating to infer the concentration based on optical properties. And this is the blade that he was showing in the picture. This is just a smaller version. So that's what rotates and makes the kind of nice shear stress parallel to the surface.
So the cushion is just the traction between the ground.
Right. So what we have on this version is this relatively soft foam, and then when you put this on any kind of a surface, it does a pretty good job in sealing around so that you don't have any leaks around.
Okay.
And then because once the instrument starts running, the dust concentration increases inside the chamber, and what you need to do is inject air at a constant flow rate so that you can figure out what the mass balance is in there, so that then you can calculate how many micrograms of PM10 you get per cubic meter of air.
Is this the kind of instrument that you plan to use on the border study that we're going to be
I think that Dave would be a better person to answer that question, but I'm thinking that he is planning to use that instrument for that study. Yes.
When you do your calibration with PM10 in the lab, I assume whatever you're using is all PM10 particle? Whatever you're using?
Right. So when they calibrate these in the labs, the TSI is the company that makes these instruments. That's what they do. I think that they generate PM10 particles and then they calibrate the instrument with that.
But now if you have it, right, evidently if you have gust of wind going in there, so you're going to get more
Right.
PM10.
So what these are also designed with, they have an impactor at the input of the instrument, so that eliminates particles bigger than 10 microns, so that what the instrument is reading is a PM10. Yeah. So I think the question was, Dave, if you were planning to use the instrument for the border study that you have coming up?
Yeah.
Okay, so yeah.
You get it started.
So you mentioned, George, you can collect a sample from the exhaust?
I didn't mention that. So as Dr. Vick says, we have also a filter sampler, and what we have is basically this control port here, and the filter sampler comes in its own case, and it has a battery and a little pump, and then basically program on the computer, when the blade starts spinning, we turn on that filter sampler, and then it collects the on a filter, we have an option of collecting PM10 or PM2.5 particles on the filter. And that's basically FRM based instruments, because we have cyclones with very sharp cut and mass flow controller. And usually when we are running this, we program it so that tests last about kind of 8 to 12 minutes duration, and we try to simulate 3 or 4 different wind speeds within that period. And I can show you quickly how you can program the instrument. It will be hard for everybody to see, but so we have a basic interface here. I'll give people a few seconds to maybe get in place. So the screen where we select what kind of test we want to run. And this is the last test which we ran. And you always remember what the last test was. So for example, these are tests where we linearly increase the wind speed inside the chamber. And these tests are kind of useful for determining the threshold at which dust emissions start to occur. But for example, it's very easy to go and select a different sense type of a test. So this is one of the tests that Rick was showing in his presentation, which we call a hybrid test. And this kind of test, we initially linearly increase the speed, and then we hold it constant. So a linear increase is kind of useful because, again, allows you to figure out what the threshold is at which dust emissions start to happen. And then the constant part is useful to figure out if your test area is supply limited or unlimited. Again, if you remember for Rick's presentation, he had one case where wind speeds went up, so the dust concentration, it kind of stayed constant. And he had another one where dust concentration went up and then came quickly down. Okay, so let's say we want to run this test. We
Sorry,
will-
just to remind you, when you actually want to run the test, we can